Today, let's talk about how to integrate by substitution. The key idea for evaluating a definite or indefinite integral is to make the integrand simpler so that we can figure out the antiderivative. Let's look at an example. I equals indefinite integral x squared plus 1 to the power of 50 times 2x dx. It is difficult for us to figure out the antiderivative because the integrand contains a composite function. To simplify the integrand, we can replace the inside function x squared plus 1 by a single variable u. So let u equals x squared plus 1. Then we take the derivative with respect to x. So du over dx equals 2x plus 0, just 2x. Multiplying both sides by dx, we get du equals 2x times dx. So you see du equals the derivative of the expression times dx. Now the given indefinite integral becomes integral this part, just u. So u to 50. And then 2x times dx actually equals du. We know the antiderivative. It is u to the power of 50 plus 1 over 50 plus 1 plus a constant c. Finally, we can replace u by x squared plus 1. So we get x squared plus 1 to the power of 51 over 51 plus c. Now let's look at next example. The indefinite integral of cosine x cubed dx. Again, the integrand is a composite function. But if we let u equals cosine x, then du would equal to negative sine x dx. But there's no sine x in the integrand, so we cannot do that. Let's try to break up the integrand to two parts. So we change that to cosine x squared times cosine x times dx. We know cosine x squared plus sine x squared equals 1. So cosine x squared equals 1 minus sine x squared. And then here's the cosine x dx. Now we can let u equal sine x. So let u equals sine x. So du equals the derivative sine x times dx, which is cosine x dx. So the given indefinite integral becomes integral 1 minus sine x squared, which is 1 minus u squared, and cosine x dx actually is du, right? So get du. We know the antiderivative, which is u minus 1 over 3 u cubed plus c. Finally, we replace u by sine x. We get sine x minus 1 over 3 sine x cubed plus c. Finally, let's look at a definite integral. I equals integral from 0 to ln 3 e to x 1 plus e to x square dx. Like before, we can let the inside function as u. So let u equals 1 plus e to x. Then du equals derivative 1 plus e to x prime dx, which is 0 plus e to x. So equals e to x dx. From there, we can solve dx by dividing both sides by e to x. So du over ex equals e to x dx over e to x. So cancel that, we get dx. And we also need to change the limit. So when x equals 0, we know u equals 1 plus e to x, so e to 0. We know e to 0 equals 1. 1 plus 1 equals 2. When x equals 2 ln 3, u equals 1 plus e to ln 3. E to ln 3, x equals 3. 3 plus 1 equals 4. So the given definite integral becomes integral from 2 to 4 e to x, and 1 plus e to x is u, so u squared dx equals du over e to x. Now we cancel e to x, so we get integral from 2 to 4 u squared du. Now we know the antiderivative, which is 1 over 3 u cubed. The upper limit 4, lower limit 2. Now we plug in 1 over 3, 4 cubed minus u equals 2, so 2 cubed. We know 1 over 3, 4 cubed equals 64. 2 cubed equals 8. 64 minus 8 equals 56. So the final answer is 56 over 3.